Myself Bala from GPC Khuni Majra. Today we will discuss about ultrasonic waves, its productions and applications. Following are the outline of my talk: introduction to ultrasonic waves, properties and its production method, and last we will discuss application and some problem related with the formulas in ultrasonic waves. First we come to know about the nature of ultrasonic waves. So before going to ultrasonic waves, we will little bit study sound waves. So sound waves are mechanical compression waves which are in general longitudinal in nature, meaning its meaning is that the particle vibrate parallel to the direction of the wave velocity, that is in the direction of wave motion the particle vibrate in the same direction. Sound waves, they are divided into three categories that are basis on the frequency ranges. First one is audible waves. As clear from the name, audible means they are we can hear these type of waves. They are within the range of the sensitivity of the human ear, so we can hear these type of waves, and the range of the human hearing is from 20 to 20,000 hertz. So the frequency of audible waves is from 20 hertz to 20,000 hertz, and they can be generated in variety of ways such as musical instrument, human voices or loudspeaker. So we can easily hear these type of sounds from 20 hertz to 20,000 hertz. Sorry. Second type of waves is infrasonic waves. These waves having frequency below the audible range, that is less than 20 hertz, that are called infrasonic waves. Elephants can use infrasonic waves to communicate with each other even when separated by many kilometers. So infrasonic waves having frequency less than 20 hertz, and it is used by elephants to communicate with each other. And the last part of the types is ultrasonic wave. Ultrasonic waves having frequency above the audible range, that is above 20,000 hertz or 20 kilohertz. So these type of waves, they are called ultrasonic waves, which we study in detail in this topic, in this lecture. So ultrasonic waves having frequency greater than 20,000 hertz, and some animals can emit these sounds like bats, etc. Here I have written an example. Bats, for example, emit and hear ultrasonic waves which they are used for locating prey and for navigating. So ultrasonic waves having frequency greater than 20,000 hertz, and some animal like bats, they emit these type of waves. Now we will revise and somewhat discuss about the characteristics of sound frequency. We know frequency is the number of times the wave oscillate through a cycle for each second, and its unit is hertz, or we can say number of cycles per second. We know infrasonic or infrasound waves, they have frequency less than 20 hertz. Audible sound or audible range is 20 hertz to 20,000 hertz, and ultrasound or ultrasonic waves having frequency 20,000 hertz or 20 kilohertz. For medical range, for medical use, we use ultrasound waves They have frequency 2 to 10 megahertz with specialized ultrasound applications up to 50 megahertz. So high frequency ultrasonic waves, they are used for medical purpose. Next definition is period. The time duration of one wave cycle, that is opposite of frequency, T time period, is equal to 1 upon f, where f is frequency of the wave. Now we come to the our topic, that is introduction to the ultrasonic waves. This word ultrasonic, it comes from the Latin word ultra. Ultra means beyond. So the ultrasonic, ultra means beyond and sonic means sound. So beyond sound, it means beyond the hearing range. So sound waves having frequency above the audible range, that is above 20,000 hertz, they are called ultrasonic waves. Generally these waves are called high frequency waves because its frequency is very high as compared to audible range as well as infrasonic range. And the field of ultrasonic have applications for imaging, detection and navigation. These applications are very important and we will discuss these applications later. And the broad sector of the society that regularly apply ultrasonic technology, they are medical community, industry, military and private citizens. So ultrasonic waves have various applications in various fields like medical, industrial, defense and private citizens. Now we will discuss how bats use ultrasonic waves for the location. So echolation is the use of reflected sound waves to determine distance or to locate objects. Animals including bats, dolphins, they use echolation to navigate and to find food. Like here we can see a bat can emit ultrasonic waves. So if there is some obstacle, these waves, they will come back. So according to that, they will find the object in front of him or her. So bats use ultrasound waves with frequency up to 100,000 hertz to move around and hunt. As bats fly, they send out short pulses of ultrasound waves. They will send 200 pulses per second. Ultrasound waves reflect off the object and return to bat's ear. The time it takes for the sound to return to the bat, it lets the bat know how far away the object is. So depending upon the time, after which time these waves are reflected back, so we can determine the distance between two objects. Next we come to the topic of properties of ultrasonic waves. As we know, the frequency of ultrasonic waves is very high, so energy is also very high. They have high energy content. Energy is directly proportional to frequency. As the frequency is high, so energy is also high of ultrasonic waves. Just like ordinary sound waves, ultrasonic waves, they get reflected, refracted and absorbed. They can be transmitted over large distance with no appreciable loss of energy. Next point is, if an arrangement is made to form stationary waves of ultrasonic in a liquid, it serves as a diffraction grating, so it is also called acoustic grating. And last important point is that these waves produce intense heating effect because their energy is high when they are passed through a substance. So, after passing through a substance, they produce intense heating effect because of high energy, high frequency. Ultrasonic waves, they can be produced by two methods. First one is magnetostriction generator, or we can see magnetostriction oscillator. Second method is piezoelectric generator or oscillator. Now we will discuss magnetostriction generator in detail. So, first its principle. It is based upon the principle of magnetostriction effect. So, what is this effect? When a ferromagnetic rod like iron or nickel is placed in the magnetic field parallel to its length, the rod experiences a small change in its length. This is called magnetostriction effect. So, here we can show in this example that a ferromagnetic rod is placed here in the magnetic field. So, when we apply magnetic field to this rod, so its length changes depending upon nature of material, and it is independent upon magnetic field applied. So, with change in length, it produces waves which are called ultrasonic waves, and this method is called magnetostriction method or oscillator. This one is magnetostriction oscillator. Here xy is rho, and these two are for induction, L1 and L2, and this is C is variable capacitor, and this is sorry, transistor. So, when we apply a high tension battery or electric field, so it due to induction it produces magnetic field. So, with this magnetic field, this rod start vibrating. So, with this vibration it produce ultrasonic waves. So, this is a picture of magnetostriction oscillator, how it works. So, we can in detail study here. XY is a rod which is made of ferromagnetic material like iron or nickel. It is clamped in the middle, here in the middle. The alternating magnetic field is generated by electronic oscillator. From this oscillator we can generate alternating magnetic field. So, L1 coil L1 and L2, these two are coils. The coil L1 bound on the right hand portion of the rod along with the variable capacitor. This capacitor with this arrow is called variable capacitor. So, this is variable capacitor, and this form the resonant circuit of the collector tuned oscillator. The frequency of this oscillator is controlled by variable capacitor. The coil L2, this coil is bound on the left hand portion of the rod, and it is connected to the base circuit, and coil L2, it acts as feedback loop. This acts as feedback loop. So, when the high tension battery is switched on, the collector circuit oscillates with the frequency. This circuit oscillate with the frequency f is equal to 1 upon 2 pi square root of L1 into C, where L1 is inductance and C is capacitance. So, this alternative current flowing through the coil L1, it produces a magnetic field which is alternating magnetic field along the length of the rod. This result is that the rod start vibrating due to a magnetostrictive effect. So the frequency of the vibration of the rod is given by n is frequency is equal to 1 upon 2 into L, where L is the length of the rod, square root of y upon rho. Y is Young modulus of the rod and rho is density of the rod material. So the frequency with which the rod vibrates or it produces ultrasonic waves is equal to 1 upon 2L y upon rho, where L is the length of the rod, y is Young modulus of the rod material and rho is density of the rod material. The capacitor C is adjusted so that the frequency of oscillator circuit is equal to the natural frequency of the rod, thus resonance takes place. Now the rods start vibrating along the longitudinal direction with maximum amplitude and it generates ultrasonic waves of high frequency from its ends. Now we come to know about the advantage and disadvantage of this method. So the advantage are the design of this oscillator is very simple and its production cost is low. And second advantage is that at low ultrasonic frequencies, the large power output can be produced without the risk of damage of the oscillatory circuit. And the disadvantage of this method is that it has low upper frequency limit and it cannot generate ultrasonic waves with frequency above 3 megahertz or 300,000 hertz. So it has limitation. This second limitation is that the frequency of oscillation it depends upon the temperature, and third is disadvantage is that there will be losses of energy due to hysteresis and eddy currents. Next we come to know about second type of generator of ultrasonic waves. This generator is called piezoelectric generator or oscillator. It is based upon the principle of inverse piezoelectric effect. Although its name is not inverse piezoelectric oscillator, but its principle it is based upon the principle of inverse piezoelectric effect. So we will come to know about this effect in detail here. If the mechanical pressure is applied to one pair of the opposite faces of certain crystal like quartz, an equal and opposite electric charge appear across its other faces. This is called piezoelectric effect. So in detail we can study here that this is the rod. Here if we apply some mechanical pressure here, so it will produce some electric effect. This is called piezoelectric effect, and its converse is called inverse piezoelectric effect. So its meaning is that if an electric field is applied to one pair of the faces, the corresponding changes in the dimension of other pair of faces of the crystal they are produced. So this is known as inverse piezoelectric effect or electrostriction. So we will study here its construction about piezoelectric oscillator. So this is crystal. The quartz crystal is placed between two metal plates A and B. These two are metal plates. This is crystal, quartz crystal. The plates are connected to the primary loop L3 or primary wire L3 of the transformer, which is inductively coupled to the electronic oscillator. This is electronic oscillator. So the electronic oscillator circuit is a base tuned oscillator circuit. Before that, that is collector tuned, but this is base tuned. This is transformer. It has three parts: ammeter, base and collector. Ammeter, base and collector. So it is attached with the base. So this is called base tuned oscillator circuit. The coil L1 and L2, these two, they are called secondary coils of the transformer. The collector coil L2, we know it is collector, this is ammeter, this is base. So the collector coil L2 is inductively coupled to the base coil L1, and the coil L1 and the variable capacitor C1, L1 and C1 form the tank circuit of the oscillator. So its working is, when we apply a high tension battery, it is switched on. So the oscillator produce high frequency is equal to same as we did, f is equal to 1 upon 2 pi L1 C1. L1 is this inductance and C1 is capacitance. So due to transformer action and oscillatory EMF, it is induced in the coil L3. This high frequency alternating voltages are fed on the plates A and B. The inverse piezoelectric effect takes place and the crystal contracts and expands alternatively. The crystal is set into mechanical vibrations. So the frequency of this vibration of the crystal is equal to P upon 2L Y upon rho square root, where P is 1, 2, 3, 4 depending upon fundamental first overtone, second overtone, third overtone. So one point should be clear here. This is called fundamental frequency. 2 is called first overtone, 3 is called second overtone, 4 is called third overtone. So L is length of the rod, Y is Young modulus of the crystal, and rho is density of the crystal or material which we used for the electrostiction effect. So the frequency is P upon 2L Y upon rho. N is frequency of the vibration, P is overtone, maybe fundamental frequency, L is length of the rod, Y is Young modulus of the crystal, rho is density of the crystal. So variable capacitor C1, it is adjusted such that the frequency of applied AC voltage is equal to natural frequency of the quartz crystal. So a resonance takes place when these two are equal. So the vibrating crystal, it produces longitudinal ultrasonic waves of large amplitude. Now we come to know the advantage and disadvantage of these type of oscillator or generators. Ultrasonic frequencies, it produces ultrasonic waves with frequency as high as possible, that is 500 megahertz. They can be produced by this method. The output of this oscillator is very high or high frequency waves, and the most important is that it is not affected by temperature and humidity. Before, the magnetostriction effect, that is affected by temperature as well as humidity, but in this method the electrostriction effect or piezoelectric oscillator, it is not affected by temperature and humidity. So now we come to know about the disadvantage of this method. The cost of piezoelectric quartz is very high. So the crystal which we used for this purpose, its cost is very high, And second disadvantage of this method is that cutting and shaping of the quartz crystal is very complex phenomena. So the first disadvantage of this type is that this crystal cost more expensive, it is very expensive. And second disadvantage is that it is very difficult to cut this crystal. Now we come to know the application of ultrasonic waves in engineering, in medical later on. So first we come to know about the application of ultrasonic waves in engineering. So it is used, ultrasonic waves, they are used for the detection of flaw in the metals. This application is called non-destructive testing, NDT. Its principle, it is based upon the principle that the ultrasonic waves are used to detect the presence of flaws or defect in the form of cracks, blowholes, porosity, etc. in the internal structure of the material. If there is a crack in the material, we can easily detect with the help of ultrasonic waves. How we can detect? By sending out ultrasonic waves and by measuring the time interval of the reflected beam. So if the ultrasonic waves is reflected back, so there is some flaw in the metal or defect in the metal. Its experimental setup is that it consists of a ultrasonic frequency generator and cathode ray oscilloscope CRO, transmitting transducer A and receiving transducer B, and an amplifier. Its working is that in flaws there is change of medium and this produces a reflection of ultrasonic at the cavities or cracks. The reflected beam is recorded by using cathode ray oscilloscope. The time interval between the initial and flow echoes, it depends upon range of flow. By examining the echoes on CRO, flaws can be detected and their sizes can be estimated. Features of this experimental setup is that this method is used to detect flaws or defects in all common structural metals and other materials like rubber tires, etc. And second feature is that the method is very cheap and of high speed of operation. And third is it is more accurate than radiography. Second application of ultrasonic wave is that it is used for drilling purpose. Ultrasonic, like we can use laser also for drilling, for cutting. So we can here we study the application of ultrasonic waves. So ultrasonic waves, they are used for drilling purpose. Ultrasonics are used for making holes in very hard material like glass, diamond, etc. For this purpose, a suitable drilling tool bit is fixed at the end of powerful ultrasonic generator. This ultrasonic generator, a bit is attached here. Some slurry or a thin paste of carbonadium powder and water is made to flow between the bit and the plate in which hole is to made. So the ultrasonic generator causes the tool bit to move up and down very quickly, and thus the slurry particles below the bit just remove some material from the plate. So this process continues and a hole is drilled in the plate. So we can use ultrasonic waves for drilling. Ultrasonic waves, they are also used for ultrasonic welding. The properties of some metals change on heating. Therefore, such metals cannot be welded by electric or gas welding. In such cases, the metallic sheets are welded together at room temperature by using ultrasonic waves. For this purpose, a hammer edge is attached to a powerful ultrasonic generator as shown in figure. So, ultrasonic waves is also